Hey folks, here at Biomerics in Monroe, Connecticut, where Chris Richardson and Arun Mohan just gave me a tour of this beautiful facility. Chris, thanks a lot for the tour. Beautiful facility. Can you tell us a little bit about yourself and the fully vertically integrated capabilities within Biomerics?
Sure, we're happy to have you here, Steve. Thanks for coming. My name's Chris Richardson. I serve as the Chief Commercial Officer for Biomerics. Been with the company 19 years, been in medtech for 19 years as well. Biomerics strives to be the leading vertically integrated contract manufacturer in the interventional markets. We do that both through plastics and metals that are integrated together into finished device assemblies. So we're here today focused on Arun's Metals Group, specifically our plant in Monroe, Connecticut, where we've been operating since 1993 with our core centers of excellence in micro machining. We have the work cell here in the background, laser cutting specifically of hypotube, laser welding, and laser marking.
Arun, this was such a beautiful facility. Can you give us an overview of the overall capabilities within the metals business, and then talk about specifically this site?
It's a long time coming to have you with us and have you walk this floor. But my name is Arun Mohan. I'm the president of the Micro Metals Group at Biomerics. Joined the company about a year ago now, and based in North Carolina, but our facilities are in Monroe, Connecticut here, Winston-Salem, North Carolina, and then Santa Clara, California, are three main micro machining or micro metals hubs. In Monroe, in this facility, and you've walked it, you've seen some of it, we'll talk more about how we strive for excellence in everything that we do, but you're standing in 75,000 square footage of manufacturing space. At this particular site, we have a focus on micro machining. You see the micro machining work center behind us. We have our laser cutting, welding, marking competencies laid out here. Our automation cells are also in the facility. Biomerics is proud of the kind of automation expertise we bring to the table. It starts here at this facility with the team lead being based here. So you'll see some of our most sophisticated automation cells in this facility. And beyond that, I mean, we're poised for growth. We have a second building that we'll show you next.
Yeah.
And it's all meant for the expansion of all of our micro machining, laser processing, metal finishing capabilities coming out of this site.
Yeah, what was really impressive is just the full suite of capabilities from micro machining, laser processing of a hypotube, and then the secondary passivation, electropolishing, putting it all together.
Now, what we pride ourselves on is to try and build relevance with our customer by adding enabling technologies and capabilities. We want them, they may come to us for one part, maybe it's micro machining, maybe it's laser cutting, but then they realize that they can get design for manufacturing expertise and help, and then they realize everything that we can do to make sure the value stream is controlled, is sustainable, helps us scale and pass on those cost savings to the customer. So, we talk about being critical enablers to our partners in the process technologies and manufacturing technologies we offer. That's what we strive to do.
I saw that in some of the applications you showed where you actually have scaled to automated robotic type solutions.
No doubt. We love to learn. I mean, look, in the end of the day, our engineers love a challenge. You'll meet with Ken and Mike and some of the other guys here. That's what feeds them, is the challenge.
Chris, what are the primary markets that you serve, and what are some of the applications for the metals business and Biomerics vertically integrated capabilities?
So Biomerics is focused on creating value in high CAGR interventional markets where technology wins and physicians are still part of the decision-making process. We pursue our vertical integration primarily in steerables for markets like structural heart, medical robotics, endoscopy, and specifically the continued trend of single-use endoscopy.
During the tour, you mentioned many times about the center of excellence, and we hear that in the industry. A lot of people talk about a certain site as the center of excellence. Is that just a marketing term, or does it really mean something? Tell me what it means to you, the center of excellence.
Sure, yeah, you'll see our core competency in component level manufacturing marketed as a center of excellence. Our centers of excellence are market focused, then down to the product level, And then we as a contract manufacturer embrace truly being process and raw material experts. So what does it mean to form a center of excellence? They're generally developed over time through volume of application. And then for us, with our strategic customers, we want to provide that level of value for the R&D or future forward thinkers in DFM collaboration, then NPI, new product introduction, into manufacturing, and ultimately scale at volume.
Okay.
So what does Biomerics deliver through this C of E? Over years of experience, we've gained that subject matter expertise across multiple markets, multiple product opportunities that lead to a critical mass in infrastructure and scale, libraries of validated test methods throughout our quality system and organization, and then ultimately that ability to scale even into low-cost country applications at volume over that product life cycle.
Okay.
So we want excellence at the MPD level, into new product introduction and scale, and then ultimately at volume as that product life cycle matures.
Yeah, and to complement what Chris mentioned about the Center of Excellence, I mean, excellence to us, the way we look at it, it's a journey, it's a mindset. It's not being happy with the status quo. You want to keep learning and keep rolling. And so for us, something when especially in the metals organization, when something reaches the level of a Center of Excellence, it's not just in the equipment and the capital that you see here, the best of the best, but it's in the people. It's in the subject matter expertise, the process experts. When we rise to that occasion, it's ready to then provide that to our customer as a C of E, because we can take it from, all the way from napkin sketch to manufacturing to scale.
Right.
And you're standing actually in one of our major facilities that kind of boasts at least 4 of those centers of excellence here.
At MPP West, we were fortunate to have Travis Sessions, your leader, give the opening remarks. He did a great job, and something that resonated with me and a lot of people was this term he used, smaller is smarter. Tell us a little bit about what that means to you specific to the micro metals business.
Yeah, well, it starts in the name. When I joined Biomerics, I said, Travis, micro, and he's like, no, that doesn't mean you're less important. That's the future, micro. So micro metals, we specialize. As you get smaller, tolerances get tighter, be much more controlled. That's where our expertise really shines through. So whether it's in the Wilhelm Swiss machining cell you see behind you, or you start to go over to our Swiss Stern machines, our laser cutters, everything is designed to, as Chris mentioned before, go where the market is growing in technology needs and design, asks of us. And as we get smaller and smarter to cater to the digital world of tomorrow, we're equipped to enable people on that journey.
Chris, we talked about all the vertically integrated capabilities, and we know that there's a lot of advantages, right, to that, controlling the supply chain. But I wanted to get your perspective on how that facilitates design for manufacturability.
Yeah, it's a great question, Steve. So there are obvious benefits to vertical integration when it comes to the BOM, simplifying the supply chain and management of supply continuity. But from a DFM perspective, we have such a broad range of capability at a component level, those come together at a product level. So when you think about a steerable device, we understand the elements of the laser cut hypotube, raw material and process technologies. That then transitions over into some sort of articulation or bending section, be it injection molding, a MIM link assembly, laser cut hypotubing as well. Then some sort of micro machine pull ring assembled together with coil pipes and laser welding, where maintaining that original wire tensile strength is essential. So having that expertise at every component level, and then ultimately delivering a finished steerable product, enables us to consider not only those components, but how they will interface with each other. So we believe that brings great value to our customer in DFM expertise from a product level that's rooted in component level technology.
Just expanding off that a little bit, design for manufacturability. You're not just a contract manufacturer, you have you can offer a lot of design input, full CDMO.
Absolutely. We offer design level services as an NRE revenue stream. It is part of our core business model, but ultimately 50+% of our revenue as a company is finished, packaged, labeled, sterile devices.
Okay.
We're in the business of building long-term strategic partnerships with our customer in scaled manufacturing.
So Steve, here in Monroe at this facility, you know, it's a 75,000 square foot facility. We have 2 buildings. There are about 220 employees in this facility. Apart from our micro machining equipment, our laser processing, which is cutting, welding, marking. We also have our Swiss turn machine cell here, automation cell, all of our metal finishing that does electropolishing, passivation, and also then HF for hypotube processing in that whole value chain. And per month out of this facility, we ship about 1 million units per month coming out of this Monroe facility. Several units go in our vertical integration chain to Costa Rica, to some of our other facilities in the Biomerics network, and several of the components and sub-assemblies will get shipped directly to our core customers.
Hey folks, here at Biomerics in an automation cell with Ken Hogue, VP of Engineering for Micro Metals, and Mike Walsh, Director for Automation. Ken, can you give us a little overview of automation? We talked a lot about design for manufacturing and a little bit about design for automation. Can you talk to us at a high level about the automation and how you approach it and the capabilities?
Yeah, as we look at automation, we really think about the volumes that the customer is going to need in the program, the scaling of a program, and really automation brings a consistency, a quality level, the ability to inspect, and risk reduction for our customers. It has to do with capacity. As we scale shifts, we're not adding more and more and more people to the line. And that consistency, that ability to scale, and that capacity really reduces the risk for our customers.
Ken, do you ever take the approach where you go from a manual process to a semi-automated, then to a full scale?
As a product scales, it's often that low volume, and those first prototypes are often made in a manual process. And at the next stage, higher volumes, you're semi-automated. You've taken a few key aspects of the job, and often the fixturing is the key to any manufacturing process. And as we take that semi-automation and we take it to full automation, we've got the highest capacity available and the most consistency and quality.
Interesting. So the fixturing is the enabler in a way.
Absolutely.
Mike, Ken did a good job giving us a high-level overview of the automation capabilities here at Biomerics. Can you dig a little deeper for us and talk about a specific application?
Yeah, so behind us we have an application that Ken was talking about just before. This is a lower volume prototype product. The volume increased. We had a semi-automated vision-guided welder that we ran this on for many years. And then as the volumes went up, we decided to fully automate it. So what you see behind here is basically all the steps that were taking place in a more manual or semi-automated approach. And we took all those and kind of applied robotics and vision to those to get the cell you see behind you.
Mike, when you approach an automation project like this, I think what might set you apart, and you can correct me if I'm wrong, the automation, you're doing that in-house. You're not, you don't have a firm do the automation cell for you. You have the capabilities,
Absolutely.
Expertise, and resources to do it in-house.
Yep. So the kind of approach we take, I call it the action out approach. So we have all our centers of excellence here. So let's take welding, for example. We have all the welding expertise right here in-house. So we sit down with our welders and we go over what the process looks like. And then we basically build the machine around it. Where do the parts come from? Where do they have to go? And then we kind of build the whole cell to kind of fit the process. So we're not worried about footprint first. We're taking care of the process first, and then we kind of build out and rings around that.
Mike, continuing to talk about automation, and I think this is interesting because of the vertically integrated capabilities, extrusion, molding, laser welding, you kind of tie it all together in this cell. But unlike the other example where maybe you started with design, and then went maybe semi-automated all the way to automation. This is a different case. Tell us about it.
Yeah, so we had to develop the automation in tandem with the process development itself. So that presents all sorts of challenges from a process standpoint where you don't have years of experience running this component to kind of lean on. So we have to be agile and quick, and we come up with a problem, we have to be on top of that with solutions. So what you see here is kind of the culmination of all those iterations, right? We get the parts in, they don't quite fit up, we got to make a change. The tolerances don't quite meet the print, we got to make a small change. So doing that is its own challenge, but we were able to accomplish that and bring in the vertical integration to kind of ramp up into a production schedule in a quick and efficient manner.
Ken, often say that in order for a manufacturer to participate in some of the high growth, high value applications such as structural heart, surgical robotics, electrophysiology, ideally you really need to have the full complement of extrusion, molding, plastics, integrated with metals capabilities and bring it all together. Tell us how you vertically integrate these different competencies.
Yeah, that's a great topic. I think we really try to match the life cycle of our customers' products and have solutions that have integration of a machine component that gets micro overmolded to a MIM component at higher volumes that could be overmolded, and then at the highest volumes integrating a metal stamping into an overmolded product or application, and trying to fulfill the full life cycle of a customer's product in that way.
When you talked about the full life cycle, you're talking about starting from almost a sketch on a napkin to manufacturing and then maybe to full automation.
That's right. We really like to get involved early with our customers to provide design for manufacturability feedback. We talked earlier about the key aspect of a manufacturing process is often the fixture. And sometimes the design of the part really impacts your ability to fixture it correctly. Our customers' design engineers are thinking about the design and the functionality of the final product. And our engineers are thinking about the manufacturing, how we're going to hold this part, how we're going to measure it, what are the key datums and tolerances of the part as we go through the manufacturing process. And all along the way, we want to provide that responsive, quick turn, prototyping, and development capabilities to serve that early stage development of a new product.
Ken, when we talked about earlier about centers of excellence, as it relates to R&D, are there certain centers of excellence or certain sites within the Micro Metals Division that cater more to the early stage R&D and then maybe transfer? Tell us a little bit about that model.
Yeah, we have all sites that participate, but we're evolving to focus on a theme called Rapid Fire Labs with a core site that will be the center point of a process of developing very quick turn capabilities focused on that very early stage development. And as needed, coordinating with all the other sites and all the other centers of excellence to bring the solution to the customer.
Hey folks, here with Dave Hornak and John Franchi. We're talking about Biomerics capabilities in single-use endoscopes. Guys, I know that over the last couple of years, there's been a trend to move from multi-use endoscopes to single-use endoscopes because of the time for processing, the potential for bacteria infections. And so a single-use endoscope, much like the work that you do in complex steerable catheters, also has to have some articulation and steerability. And I understand that you've developed and have a patent on the backbone or articulation member of a single-use endoscope that you can share with us, Dave.
That's correct. This was born out of the necessity to reduce cost. We've saw that the cost of getting the bending section from our supplier that we were working with was very costly. Sometimes the lead times were very long, and we just, as a laser cutting facility, we saw that there was an opportunity that we can could produce something very similar to what they were getting, but in a much easier manner to procure it in. And so we came up with this design, inner two tubes, tube within a tube, and you can see how it will move within it. You've got a puzzle piece up here. It's captured within two tubes, and we laser weld here. So we use our laser welding ability as well as our laser cutting. So this is a hypotube within a hypotube, two sizes that fit within a tight tolerance that we can then manufacture and produce at a pretty inexpensive cost on this.
John, if you used a laser cut hypotube and put a cut pattern in for a solution like this, I think you might be limited with the degrees of articulation. But it seems like here you have multiple degrees of articulation.
Yeah, that's right. Most of these are made using either MIM parts, machine parts, and they end up being complicated and costly, and you have to stack them up, assemble them, snap them together. If you're trying to get your control wires, you may have to drill holes, small holes, so very complicated. And what we wanted to do was kind of make something, as Dave said, out of tubing. And hypotube is very inexpensive. But what we do is by creating an inner and an outer, we were able to basically create the features that you might have in a machine part, but simply by putting some of those features on the inside and some of them on the outside, everything including locking features, everything including cable management. And you're absolutely right. If you try to do this out of one tube, as soon as you try to get four axes of motion, the assembly falls apart. It's just there's too many ways for the pieces to come apart. The locking design with inner and outer, you've got one part of it locking it from moving in one direction, and the other part of it locking it so that it rotates. And that just made it relatively simple to manufacture. There are some features that we're able to put into this, like cable management on the end that we're seeing right now, as well as cable management throughout, where you're seeing the little hoops there. Those are all part of the laser cut hypotube section, and we can take these and assemble them, and just with tacking them together to just prevent them from moving around relative to one another. We're able to make this assembly, which is extremely versatile, extremely strong. The welds do not take any of the stresses. The stresses are all held by the interlocking puzzle type of architecture.
Interesting.
Yeah, the welds are only there really to hold it together from one tube falling apart from the other. The other thing taken into account with these pull wires is that it's a four-way steering on this, but it also, there's no welding on those as well. Just the weld is just to hold it in place. All the strength of the wire comes from the bend that you see on the end of that.
And with this design, we can make it bigger, we can make it smaller, we can use different hypotube sizes, we can make different angles that it can articulate through. We have a way of manufacturing it so that when we do weld it together, we can pin each part, and that also lends itself to high production automated manufacture. We could feed these into a bowl and have them all put together and welded together, make sections as long as we want, as small as we want. We can make the end sections just slightly different so that they can attach to either the proximal or the distal end of the mating component.
Interesting.
So what you see is the holes in there on both the inner and outer rings. We put locating pins through, and we can weld the whole link assembly up with one fixture, tooling all of them together, and then programming the welder to weld each one of those individually. So,
can you talk a little bit about how this sub-assembly can be integrated into a full single-use endoscope with the additional capabilities that you have within Biomerics?
Sure. So, so we can then put onto the end of this. You can, what you're seeing right here, you can put on the distal end. You can put whatever you want. You can put a machine part, you can put a plastic part, you can put another 2-part that would hold your camera, your working channel, LEDs, and on the other end you can put something that holds your coil pipes that you need, and the rest of your laser cut hypotube, braided shaft. So now you've got this section that can be put right in between that gives you the articulation. But then you are attached to another longer section. You can then do a sheath over the top of it. You can do whatever you want over the top of it, and
And all of those other things can be done within the Biomerics family.
Okay.
The other facilities can do the braided shaft for us, and we can do the laser cut hypotube that extends further down from this. That'll house the coil pipes.
Yeah, we can go all the way back to the handle and the articulation features in the handle. So, being that Biomerics does do finished devices, this is kind of, as you said, this is the backbone. We have other facilities that can put on each thing that we need. We can even do final assembly down in a low-cost country like Costa Rica, and this can go, be packaged and sterilized and sent wherever.
Excellent. Thanks, guys. Hey, folks, here with Matt Hornak, Commercial Director at Biomerics Micro Metals. Matt, thanks for showing us some of these samples. And I want to go through a few of these with me.
Awesome.
Okay, let's start with the Swiss machine laser processed parts. We have a few interesting parts here, if you can kind of go through what we're looking at here.
Yeah, so with the laser Swiss, it allows us to do not only just, the laser operations with a femto, fiber cutter, but also able to do the normal Swiss machining factors of it. So this one is more of a focus on the size, and it allows us to do a flexible shaft. We have a kerf cut here, keeps it flexible for the pull wires and everything to go through it for the robotic application that this will go into. Then we have something more suitable for the single operation aspect of it, where we have the normal step down in terms of the Swiss machining, as well as the holes, the end features, all of that is laser cut as well. So it allows us to be competitive. It allows us to, continue to excel and not only be, looking towards the feasibility side of it, but looking towards the capacity as well. It allows us to run lights out. It allows us to run unmanned as well, which is really that separation between us and another competitor.
Interesting. Now we have some components that were laser processed with femto and fiber.
Yes.
Talk to us a little bit about some of these samples.
So again, a lot of these are medical applications. So a lot of it is in the steerable aspect of things. So we have a lot of, again, different applications. We have a single femto cutter that's usually for, the very precise. We can even get down to sharps as well. But a lot of that is very minimal heat affected zone, but also able to focus on materials like nitinol, materials like titanium, as well as we do stainless steel as well on that. But for the higher running things, for the multiple, so flexible shafts.
Yeah.
We want to focus on this. This is speed, all about speed and being able to be consistent cutting.
Yeah.
So what we're doing is these are all fiber. We have about 6 machines that can handle that. And then that allows us to not only cut very, very small features, but also be very precise. And then as well, on top of that, we do have in-house post operations. So we have passivation, electropolishing, we have HF, so we have pickling applications as well. And a lot of that application has to do with getting rid of the burrs and getting rid of the soot that the laser creates as well. So it creates a really nice matte finish. It creates a really nice clean cut so that, any testing, any application will be successful.
Are there any processes that can be applied to the surfaces of a laser cut hypotube to support a secondary operation, such as maybe a covering over a hypotube or a stent or something like that?
So we do have a lot of applications that we also want to bring to the table as well. It's, we can do cutting, that's great and all, but we also have other applications, whether that's welding or whether that's marking and ablation. So I know that there's a lot of people where the glue, so the ability for an overmold or an extrusion to be able to adhere to the tube is key. A lot of people come to us and say, hey, can you guys bead blast this? And every single time we're going to offer that ablation step as well, because not only can we match the bead blast finish, but reusables are gone. We can do it a lot quicker. And then we have tooling in-house that we make to allow us to adapt it and keep up with any capacity that might be out there.
Interesting. Matt, as you were giving me the plant tour, I just see racks and racks of inventory of hypotubes.
Yeah.
So I wanted to ask, what is the size range that you work with along with the materials as well?
Exactly. So what we mentioned before, we have obviously the laser Swiss. Those are for, the higher running production. We have, as you'll see here, we have a component behind us that, we're doing upwards of 15,000 to 20,000 a week. We have bar feeders to allow us to, again, run lights out, keep up with production running 3 shifts here. But not only that, but we also are able to keep a bigger size, bigger wall thickness. So what we're able to get up to is right around 3/4 of an inch in diameter. And then that's mostly with the laser Swiss. With the laser cutters, we are able to get down to a much smaller size. So we can do things down towards the 18 thou in diameter range. And even a wall thickness of around 2 thou. So we have a really good range, but also, again, scalability is what we want to do. So we want to be there at the very beginning with you. And what we'll do is we'll focus more on the laser cutting side, if we're able to, with the MPI work, quick iteration, feedback, and then quick changes. The other thing we want to do is, continue to scale, continue to work with you to make a component that is manufacturable. That's a really big key for us. We want you to be successful, and it is a partnership at the end of the day that we want to be there for, and we want to be there through the whole life cycle as well.
Yeah, that was a couple themes that I've heard today: is design for manufacturability and also design for automation.
Exactly. Yeah. So similar to laser cutters have a unlimited feed ability where it's something again like the ability to load bars in and continue to run for 4 hours with being unattended. That goes hand in hand with again our welding, our marking, and the ability to incorporate all of those aspects. And whether it's robotic feeding or whether it's automated in-process inspection, dimensionals. That's the next tier that we're trying to get into and continue to grow and expand in.
Excellent.